So not only have I been lecturing to the abyss on the wrong screen there, I've also been completely inaudible because I was muted. Okay. Yeah, I was just muted. Oh, wonderful. Okay, we're starting the lecture over. Obviously, since no one could see or hear anything, so that was okay. Yeah, I've been talking to myself for about 7-8 minutes. Yeah, okay, we're doing this again. Okay. So, today we're talking about listen loops. Actually, today I've already talked about it, but you didn't hear it, so we're going to do it again. So, last time we talked about two different types of loops. We talked about for I loops and for each loops. For I loops are basically for index loops. They iterate through a series of indices of a list or a string. Alright, fine, I'll mod you if you want. Okay. So, and then a for each loop goes through each element and asks, or a for each loop iterates through a series of elements in a list. So, and then some loops are kind of mixed, some loops are kind of both, but most loops are probably one or the other, and you'll see examples of that right now. So let's switch over to the code and look for some examples of for I and for each loops. So, okay, let's get rid of all this. I mean, I'm going to retype it, but okay. So let's do a for I loop, right? So a for I loop looks through the indices. Let's say that we do, let's pick something better. Someone should have checked OBS before he talked to himself. Okay. So, someone, we're not going to name names, should have checked OBS, but he didn't. So, let's do the for each loop first. I'm changing it up from what I did before everyone could hear. So here's for word in my list, right? And we're going to print out the word, and that's it. So here is a for each loop. So there we are. Yeah, really the mods on YouTube, we basically use them to get rid of, once in every like 2 or 3 lectures, there will be some random person from probably outside of this class who somehow finds a link to this. And they start saying nonsense and they have to be deleted. So that's usually what their purpose is. Anyway, okay, so that's a for each loop. So basically what it did was it looked through the words in my list and it just printed them. So if we can even execute more code in here. So for instance, if we say, remember how to find the 0th element. So if we say word 0, right, is equal to S, then let's print the word. So what this will do is it'll check the first letter against S, and so it should be someone should, and then nothing else, right? Someone should. And that's right. So those are the only 2 S words. So, so now let's look for the for I loop, or let's make the for I loop. Oh, that's cute. So let's do it the for I way. So if I in range len my list, and then we can even do the same piece of code here. The only thing is we have to change. There's no such thing as word anymore. Word doesn't exist. We actually have to access it in my list. So we have to pull out my list at I, and that is the element that we're accessing. So as I goes through 0 up to what is it going to go through? 1, 2, 3, 4, 5, 6, 7, 8, 9. Can you get the first letter of the first word in the list? Yeah, you can do that. So if you wanted the first letter of the first word, you can just go mylist 0, 0, which should just print out a single S. So you see here, it'll just print out S from someone. Yep. And of course you might think that this is some kind of like two-dimensional array, and it's basically operating like that. Really what's happening is that this index is going into the list and it's picking out this element. And then this element, this index is going into the string. A string is very similar to a list. I don't want to say that a string is identical to a list, but it's very similar to a list, yes. There's one or two ways in which a string is not a list, and I'll explain those probably today, actually. So, okay. Let's input 5 things for I in range 5. Now, of course, you might say, is this a for I or a for each loop? I don't know. I guess you could call it a for I loop, but really it doesn't matter because we're going to make list of things equals new list. And then we're going to do list of things. Yeah, you can concatenate, but you can't append, right? So there's ways to join and concatenate strings, but they're different than append. Tell me a thing. And so let's do this. Let's go through 5 things and just see what happens. So yeah, tell me a thing. The thing is going to be Fruit Loops, Damascus, for loops. What's another thing? Camera. Jeez. Good. Okay, so we've just input 5 things, and I didn't do anything with them. I don't know why I did that. So we've just made a list of 5 things. We should actually do something with them next time. So let's print out the list of things. And then I want to show you an example. So if I say for word in list of things, what I'm going to do is I'm going to set word equal to happy. Okay? And then we're going to print out the list of things again after we do this, right? So this is going through. Now don't, ignore the fact that it's telling you something here. Redeclared word. Oh, actually, it's not even mad at you for the right reason. So we're going to do it anyway, and we're going to see something. So all right. Let's see. Robot, camera, TV, person. So, okay, yeah, you're about to get some TA who will give you a timeout. So, okay. All right, so what do we think is going to happen? So if we do this here, what you'll notice is that the list here, we added 5 things to this list, we printed out the list, we supposedly, right, so supposedly, we modified the list, right? Well, we modified this variable here, and we changed everything to happy. But you notice that here it didn't modify. So this is kind of an issue in Python. It's something that it's not very explicit, and it'd be cool if there was a way around this. But there are ways around this, but they're not as good. So here's what the problem is. The problem is that what is actually happening here is when it does for word in list of things, it's making a copy of the word, basically, into this word variable. So it's not actually referencing directly the memory address, the location of this word here. It actually makes a copy of the word. So when you reassign the word here, it doesn't change the list. So you might ask, well, how do we really change the list, right? If you actually wanted to change the list. And so here's how you would do it if you wanted to. So you don't have to make a new list, but you do have to modify the list. You actually have to use a for I loop to do it. So let's do it this way, for I in range len list of things. And then what we get to do, now we can change, so if you do list of things at I is equal to happy. So let's print out the list of things here. Actually, let's cut this here, paste this here with the right comment, and then paste this here, and then will it work? Right? Will it float? Will it bend? So here, tell me a thing. Student. A trope. Meson. Durable. Finite. So, okay. So what do we see here? So we see that we've entered 5 things. In the first list, this is the original list, so we're happy. Here is the for each loop attempt, right? Where we modify it like this, and it's not liking it, but who cares? Just let it be. So it doesn't change anything because it's a for each loop. But then here, with this for I loop, when you actually access the address, the place where the thing is stored, list of things subscript I, that is actually allowing you to assign to that position. And so now you see that everything is happy, pretty literally. So that's the difference between a for I loop and a for each loop mostly. That's 95% of the difference. So basically, what is the moral of the story? The moral of the story is, if you need to modify elements, clearly you can't do that with a for each loop, but you can do that with a for I loop, right? And so if you need to modify, well, they're better if you need to modify the elements. If you just need to read the elements, then a for each loop is fine. And actually, for each loops are kind of cleaner grammatically, syntactically, right? So they're nicer, but this one just didn't work. And the reason why it didn't work is because for each loops make copies of immutable objects, something that's a term I haven't defined. So for each loops make copies of the things that of immutable objects. And if you were wondering what I mean by immutable objects, currently I just mean int, float, bool, string. So that's what I really mean currently, but we'll get into mutability later. So for each loops make copies, for I loops access a list at a particular place and allow assignment. So that's the moral of the story. That's the actual difference between a for each loop and a for I loop. You can, so for each loops are mainly for access. For I loops, how can you modify a list that a for loop is iterating over? All the basic data types, int, float, bool, string, they're all technically immutable. At least they're considered immutable by Python. You might be able to, you can say, but actually you can change them and this and that and this and that. I understand. Like the term immutable is being abused a little bit by Python, but I'm using the term in the way that Python does. So I don't want to go back and say, I don't want to get too confused by the term. But yeah, so, yep. So yeah, basically if you ever need to modify a list, then you have to do it with a for I loop. Okay. And so, yeah, so let's... And if you're wondering what immutable means, it means that we can't change it. So, for instance, if I take my string and let's set that string to happy for no reason, and then my string, let's say I try to assign my string 3 equals z, print my string. So you might notice that PyCharm has a little bit of a thing here. It says string does not define set item, so that the operator cannot be used on its instances, blah blah blah, who cares. But actually what's going to happen is, well, let's tell it some things. A, B, C, D, E. It's going to say type error. String does not support item assignment, right? So what that means is that in this case, you cannot change a single letter in a string. Once you've created a string, that string is basically fixed. It cannot be modified. So I'm gonna have to comment this line out because I'll just comment all three of these lines out because they are errors, right? Or at least this one is an error because it tries to modify an unmodifiable type. Yeah, basically, unfortunately, what you have to do is a bunch of trickery. There's a lot of ways to do it, but most of it involves some kind of annoying trickery to do, which, okay, I mean, it's totally possible, and we'll go over that in a few lectures, but, you know, it's just annoying. Okay. All right, so that's the list of things. That's how everything is working. So let's think about some other examples. Let's see. Yeah, so if you have a list of integers, so for instance, if you want to make the list of integers from, say, 1 to x, and we say x equals int input, what is the maximum integer you want in your list? And so what we're going to do is you can actually use the range object this way. You can say range x, but actually, is that what you want? You want the integers from range 1 to x. So we'll start at 1. Remember that there are arguments to range. Range has the arguments start, stop, and step. Yep. So range has the arguments start, stop, and step. So normally you don't need to use step, and we won't need to use it in this case because we're stepping by 1. Remember, step is always 1. Start by default is 0, and then stop is the one thing that you have to define. So you have to define start, and you have to define step, but you don't. Or I'm sorry, you don't have to do start or step, but you always have to do stop because it's not a default argument. So okay. But remember what range does. Range always goes up to x, but not equal to x. So here we are. So this is how to get up to there. And then you can use the list keyword, the list keyword, to convert this range object into a list object. So you can say my int list is equal to this. So let's see what happens if we print out my int list. Okay, it doesn't. Okay, I was concerned. I was like, what is it not like about all of this? It looked like had a lot of issues with it, but it really didn't. So A. So what's the maximum integer you want in your list? Let's say that the maximum integer we want is 47. So here, it prints out a list of numbers between 1 and 47, like this. So that's basically how this works, okay? So the range object is an interesting thing. It doesn't actually evaluate until you cast it to a list. So remember how you can cast things to strings, you can cast things to floats, you can cast them to bools. You can also cast things to lists. And so this is how you do it. So this is how you take an iterable object and cast it. So you generally cannot cast, you can't cast ints, floats, or bools to lists, as far as I know. I guess I've never actually tried it. What does this do? I mean, I hope it gives an error, but maybe it doesn't. Yeah, it needs to be an iterable type. So, what's the maximum integer? I want 3. Then hopefully it gives me some kind of value error, type error, whatever, something like that. Yep. Because it says int object is not iterable. Okay, so you can't convert ints, floats, and bools, but you notice the one I didn't say. So I left one out, and that one is strings. You can cast strings into lists. So that's interesting, right? I tell you that you can't modify a string as a string, right? And you've seen that here because I've tried to change one of the characters into a Z, and you can't do that. So, yeah. So how do we cast a string into a list? So let's make a string. Here is a string that is normally immutable, right? And then what we get to do is go list of my string, and then we say new string is equal to the list of my string. So what is that doing, right? So what that's doing is it's taking a string and it's converting it into basically its underlying list. So every string is really kind of a list, but it's not modifiable. There's a lot of problems, you know, that make it different from it, and it's just a very different object. But underneath everything, right, there's actually kind of a list going on in there. So if we print out my string and then my list, yeah, what am I doing? New string. So new string is actually a list, so really I should call it new list. There we go. Let's print them out and see what happens. So tell me a thing. Let's do A. What's the number of things that you want? You want 54 things for no reason. Okay. And then here what we have, notice instead of having a string, so this is the printed out string, here we have a list, and you notice what it did when you cast it. It did this very specific function, which is actually really helpful to us. It split up the string into its individual characters. So it split the string into its individual characters. Nice. And so now you can modify. So if you wanted to say modify, let's modify the thing at position 3, right? So this is position 0, 1, 2, 3. Let's make it into a Z, so new list at 3 is going to be equal to Z. And then what we can do, and this is something that won't really be formally taught into the rest of the lecture, but if you want to put it back into a string, you can do this weird thing. You can do empty string.join new list, like this. So let's print out the new list. Is there buffering? I haven't seen it. I think we're still okay. I'm gonna think we are still probably okay. So what's the maximum integer? I want 12. Sometimes YouTube does some buffering issues. All I can tell you is that I don't believe it's actually on my end. Since, let me pull up OBS right now. It looks like I'm having a good upload. So I think it must have just been YouTube glitching out for a second rather than my internet connection. So that's good. Okay. So, okay. So let's take a look at what we just did. Right, so what did we just do? What we did was we took a string, we cast it into a list. So once it goes through this list constructor, it becomes a list. So now here we have new list. Here's the list that it became, right? Oh, I did see buffering for just a second. That was I caught you, YouTube. I caught you. So, anyway. So here it is as a list. So it breaks it up into individual characters. So that's pretty nice. And then what we do is we can replace an individual character now inside of a list, right? We could also replace this with an entirely new string. There's no reason that you don't have to. You could say, this is a new string we are going to put into position. Right? This is a new string that we're going to put into position 3. we could do the same thing. So you notice that here we've stuck in an entirely new string. So when join does not require this list to be of single characters. Join will add all the strings in a list together into one string, separated by the character string whatever that you have first. So this thing here is the separator. Okay? And we'll go over that more when we talk about the string lectures, but I think it's good just for this, since I wanted to use it, and there we are. So, okay. Good. We haven't done removing from a list yet. Let's do that. So how do we remove from a list? So generally, there's two ways to remove from a list. You can either remove by index, or you can remove by element. Okay? And I think at this point, I think there's good enough reason to teach both. So I'll do that. So here's the thing. Okay. So let's begin. So how do you remove by element? So removing by element means that you're going to remove an element with a specific value. So let me show you how to do this. So let's have a list. So we can have 1, 2, 3, 4, 5, 6, 7, 8. Or, okay. And then what we're going to do is we're going to print out the test list just to make sure you know I'm not holding anything. There's no cards up my sleeve. And then test list dot remove, say the number 5. Now, you know what? We should actually do 1, 2, 4, like 9. This should not be here. This should be like 13, 21. We'll put 5 here, and then 8 can be, well, let's make this 77. So the point is that this is position 0, this is position 1, this is position 2, 3, 4, this is position 5, this is position 5 here. So let's not do 5, let's say that this is 1679. So, alright. So let's remove element 21. And I want to make this very clear. So the reason why I changed the numbers was just to remove any possible confusion between the element and the index, because I had the thing at index 5, right? And then we had 5 at index 6, and that might have been confusing. So, okay, let's see what happens when we remove 21, and then we'll print the test list again. Actually, I don't think we need any of the stuff before this, so we can just tab false. So why is this, well, let's see what happens. There we go, right? So this is how to remove by element, right? Remove scans for the first instance of the element that you put in, and it removes it, okay? So for instance, if you scan for something that's not in there, let's say that we try to remove 91, then you're going to get a value error, list.remove x not in list. So why did we get the error? We got the error because there is no 91 in the list. If we put a 91 in the list, that will fix this error. But let me take it out again and let me explain something. So I think it's important to talk about this just for a second. You notice here two things happened. And so one thing that happened was the error occurs after the print statements. But if you remember the last run, oh, that's weird. Here, the error occurs sometime in the middle of the print statements, Can we actually get it to happen completely before? Yes. No, that was after. Yes. 3. The error occurs entirely before, right? I'll put this in quotation marks. The line of code that removes. So what's happening here? Could you do list.remove? Yes, you could. In fact, you could. So you could always do something like that. You could say, if I want to remove by index, I could remove the thing at like test list 5. This would work, right? This works. Yes, this works. So, so that's the right way to do it. Is just to remove. If you know the index of the thing, you can remove it like this. That's good. But what's happening here, right? Why is this red error text occurring at different times, right? Because we see that all of this stuff never executes. Really, this is the start of our program. So this line executes, then the print statement executes, then this line executes, which it does remove, and then this print executes, and then this remove executes. So how did it know that this remove was going to fail before it even got to it, right? Because it wouldn't even get to it until after this print statement. How did it know that it gets there before the print statement, right? So the actual answer is it doesn't, right? It doesn't know that the error is going to occur. It's not predicting the future. This is because there's 2 output streams in Windows and Linux and all this stuff. So there is standard out, which is the standard output stream that print writes to. Also input, right? Input reads from standard in, but it also, the input function in Python also prints the prompt out to standard out. So there's 2 streams here. There's the standard out stream, and then there's also standard error, which is a separate stream that is provided by the OS. And so here's the thing. The trick to this is that they're not synchronized. So the reason why I'm saying that is because they don't always output at the same time. So if standard out gets a message and standard error gets a message, then even if standard error gets that message second, it might actually print the message first, or the print statement might come out first. The reason is because they are 2 separate output streams, and like millisecond for millisecond, they're not 100% synchronized. So they don't wait until, like, standard out doesn't wait until standard error has output all of its errors, and standard error doesn't wait for standard out to have output all the things from the print statement. And generally, standard out is like slightly slower than standard error. So that's why sometimes you'll see errors pop out before they can even happen. So that's just one bit of notice. Like, you always have to look at the last actual print statement to know where your error actually is in your program. Because if you just think, oh, my error must have happened before these print statements, then the answer is that you're looking in the wrong place. The error actually happened after these print statements. The error happened right here. It's just that, you know, we the 2 streams are async. Okay, so yeah, so let's go back to removing. So here's how to remove. You can remove like that. You can say, you know, if you know the index, you can always would just do this. Like test list 2, for instance. Then we can print out the test list again. Let's comment out the bad line. So, oh wait, no, that actually will work, but let's remove this line anyway. So, what was the thing that I tried to do that was bad? What did I try to do? Test list.remove 91, right? Okay. So this is how how to remove a specific element, like this. And so you see that here we're removing some elements from the list. There's another way that I think I'm going to legalize this semester because there's no real reason that it was illegal. I don't think there's, but you just have to understand the distinction between them. So this is removing by element. So for instance, if there's, let's do one last thing about, let's say that in this test list we have, let's put some more 2's in here. So 2, and let's put a 2 here. So you notice there's a 2 here. So what's going to happen if I don't remove test list 2? What if I actually remove element 2? Right. So this is removing by element. And so let's do it. So you notice that it doesn't remove all the 2's, right? It removed exactly the first 2 it found. Okay, so there's a lot of ways to be safe about this, but yeah, so basically it only removes, yes, exactly. It searches through the entire list, it finds the first instance of the thing you're looking for, and it removes that. So even if there's other 2's in the list, it's not going to remove them because you have to do this multiple times. So, cool. And then the last thing I want to say is, remember how you have to make sure that the thing is inside the list before you do this operation. Well, how do you make sure that the something is inside the list? So you can say if 91 is in test list, then test list.remove 91, else we can print 91. Well, even x, let's just make it x. And so x equals int input, tell me x to remove. And so then what we can do here is say remove x. And so we will say print test list after that. Otherwise we say x was not in the list, but we caught the error for it. So notice here what we did. We said if x in test list. So this is kind of like the mathematical notation. If you've ever seen the set notation, that little epsilon symbol, that means is an element of. That's what this in is doing right here. It's asking, is x inside of this list? And so that's what that's doing. So let's actually do this. So tell me x to remove. Let's say that we try to remove 11. And so here it's going to say 11 was not on the list, but we caught the error for you. If we say remove 9, then it'll just remove it, and then it prints the list out again. Say we want to remove 13, or say 1679. Let's remove that one. Okay. And I don't know. And then let's remove 512. So 512 wasn't in the list. So this is the way that you basically want to make sure that you don't get an element. You don't accidentally try to remove an element that's not in your list. Okay, so that's something. So basically this in notation, right, in keyword is basically the same as this for loop. Okay, and so we say for element in test list, if element is equal to x, then we will set found equal to true. And before we go into here, we'll set found equal to false because it wasn't declared. So this is like a standard search that you would do through a list, right? So you would set found equal to false. And why do we set found equal to false first? We do it first because if none of these if statements are ever executed, right? If none of these ever happen, then we're just going to scan through everything in the list, and then just false is going to pop out inside of found. Otherwise, for element in test list. So let's input x again, just because x might not be the same. Well, let's do it before we remove it. That way we're in safer waters. So So what we can do here is we can say print found, right? And so let's run this thing. So the first thing it's going to do is try to find it. So it's either going to print true or false. Is there any way to remove all the 2's at the same time? Let's see. I mean, probably. No, not really. The only way to do it is a while loop. You can say while 2 is in test list, test list dot remove 2. So this will do, but you might say, well, what's a while loop? And my answer to that is no idea. What is this? So yeah, when we teach while loops, we'll teach while loops next week. So you know, it'd be nice if there was like a dot remove all or something, but there isn't. You know, there's just a remove. So anyway, okay. So let's go back to this. So let's enter the X to remove. And the first thing, remember, it's going to search for it and print the found equals true or false. So let's search for 9, right? A while loop is a while loop. That's exactly right. So yeah, so basically it found it, right? So it tells us true. And so you notice that this bit of code here is basically identical to this statement right here. And so this in keyword is actually doing a lot of work for us. It's basically pulling a for loop outside of, it's pulling a for loop out of our, it's pulling a for loop out. The other way to do the removal, if you want to remove all the 2's, for instance, is you could do for x in test list, or actually, I guess you could do for y in test list. If y is equal to x, then you could do dot remove x, and that should do it. But it's I would say for loops are generally superior. While loops are more general, so more things can be done with while loops than for loops. But while loops also come with their drawbacks. They're more dangerous. So, infinite loops don't really happen with for loops, but they can with while loops. So there's a lot of things that while loops give you, and then there's some prices that while loops exact. So the reason why I'm teaching for loops first is because for loops are basically when you write your code, 95% of your loops are going to be for loops. 5% are going to be while loops. Of course, when you do your first for loop homework, they're all going to be for loops. But the point is that when you get out into the like life world, it's just kind of a statistical fact. You're going to write a lot more for loops in your life than you'll ever write while loops. And I mean, it'd be nice if you could come up with a way to make while loops a little bit less dangerous, or a little bit more practical. But yeah, anyway. So, but it's a nature of the beast. So okay, so this will also remove all the 2's. So let's do that. Let's see if this does it without error. So print test list, and then let's run it. So let's say remove all the 2's. And okay, so it actually did. So you notice that the first time it does the remove, it removes this 2 and it becomes this. And then the second, so this code here executes and then it removes all of them. All right, so that's basically, I mean, what else should I say about for loops? Well, you can nest for loops. So as I was showing last time, I think I was showing something like this. You can make a grid out of for loops. So you can say for I in range len, say 10, for j in range len 10. And then what we can do, oh wait, crap, I'm an idiot. Not len of 10. 10 doesn't have a len. There we are. I was just on autopilot for a second. we can print out, and let's print out this particular thing, which I think I can kind of make a little bit easier on myself if I just do it like this. Which you're completely allowed to do this. Nothing about this string formatting stuff is illegal. I'm not going to spend too much time explaining what's going on here, except to say that it detects these braces, and it replaces whatever in here into that brace, and then it replaces whatever is here into this brace. And yes, that is exactly how you iterate through a two-dimensional list. And I'll show you. Two-dimensional lists will probably come up next time. I don't like to spam too many concepts at people too fast, because 2D lists are definitely something that people struggle with in a serious way. So let's see. Cool. Okay. I don't need sep, I just need end. Okay, cool. And now let's do this again because I'm stupid. Here we go. Let's actually make this an input. So let's say int input how big the grid. Right, and so finally we can make a meaningful variable named grid size. Right, so if you want a grid, there we go. So let's make a grid. And how big should the grid be? The grid should be, say, 5, just so that it's visible. So basically here, this is how grids work in most of computer science, and this is kind of how it works in with lists and indices and everything. So this is index, this is like the first index is 0, the second index is 0. The first index is 0, the second index is 1, then you get 0, 2, 0, 3, 0, 4. How big the grid, I thought that would amuse you. And then here we go down and we say, this is the first row, right? So this you might call the 0th row if you're like a true computer science type dude or dudette, I suppose. And so here you have the 0th row. Here you have the first row. Here you have the second row, the third row, and the fourth row. There is no 5th row because that's just how we're indexing, right? So basically, yeah. So this is how you would do it. The grid doesn't have to be the same size. We could change the size of the grid, so we could do something like this. Let's do something like this. Let's say we remove 1. How big the grid? Let's make the grid 2. And so you see here, the grid has 2 rows, but it actually has 6 columns because I multiplied the grid size by 3 here. So the trickiest thing, which I usually assign to some kind of homework problem, and I really do love this as a homework problem, but I probably won't assign it, so you aren't penalized for grammar. You're penalized for Python grammar. Your Python grammar has to be perfect. Your English grammar can be amusing or stupid. So let's see. Grid width, and then let's say grid height. So let's make this grid width, and let's make this grid height. So grid height, grid width. Okay, and then let's, instead of drawing the positions, let's just print out like a star. And remember, I'm changing end equals to this because I don't want, this has to be in a string. I was like, why is it giving me an error? Why is that an error? It's an error because it's not a string. There we go. So, so we're going to print out a little asterisk, and the end is going to be this so that it doesn't end line. Actually, I'll put a space just to make it nice and visible. So, 3, grid width, 5, grid height, 18. Let's see what happens. Black. So, okay, there we are. So this is now a grid with width 5 and height 18, right? So that's how you can draw grids. And of course you might be like, well, okay, drawing grids is a very specific application. Like, why are you spending more than like 5 seconds on drawing grids? The answer is, grids are the way to think about 2D lists when we get to them. In fact, I can talk about 2D lists right now if you want. So let's say that we have something like this, where we have my string grid is going to be equal to, say, hello, robot, since that's also 5 letters, happy, I always use these words. What's another 5-letter word? Nope. Wood? Yep. Fluffy. That's not 6, is it? That's 6. Fluff. Yeah. 5 with an exclamation point. Words. Right? So, cool. So what we're going to do here is I'm going to go through this. Like this. And then I'm going to also do for j in range len. And then this is the thing you have to do. So you can't just take the length of this anymore, because the length of this is 1, 2, 3, 4, 5, 6, 7, right? The length of that is 7. That is actually a 5-letter word. Happy is a 5-letter word. I guess puppy. I go with that. 8 is a 5-letter word. That's good. So it's good I wasn't asking for 4-letter words, because, you know. Okay, so we're gonna, and so this is how you have to do it. Now all of them are 5 length, so they should all just be 5. But here, what this is doing is it's accessing the string at index I, and then it's feeding it back into the length. So it's going to get the number of letters in each particular word, and then it's going to feed it back. So they don't all have to be 5-letter words. I just did that so that it would be a nice grid-looking thing. You know, you say his name, but you neglect your own. Okay, yeah, so then what we're going to do is we're going to print out my string grid at position I, j, like this. And then here we're going to print out, so remember what this is doing here. This is to print out the end line at the end of each row. So, okay, let's do this. That's right, it is. That's right. Okay, how big is the grid? 5. Okay, grid width 2, grid height 4. Okay, cool. All right. So you see what's happening here, right? This is accessing the 0th element of the 0th string, the first element, right? Now the E is the first element of the 0th string, the second element, the 3rd element, and the 4th element, right? So it's accessing each one individually. And I can prove to you that it's doing this because we could always maybe say, okay, don't print out the vowels. So if my string grid, ij, is in A, E, I, O, and U, then we can print a space, else print out the letter. So let's see what happens here. Five, 5, everything's 5. So here you see what we've done, right? We've printed out the entire grid, except we've not printed out any of the vowels. So I guess, and y here, y and w, and anyway, w is a weird one. It's kind of a half consonant, half vowel. Y is definitely a vowel most of the time, which is always amusing because it never counts as a vowel, but it's almost always a vowel. Let's add it to the list. You're added to the list now, y. So I think that should be a 201 rule, is that y is always a vowel. Okay, so basically here, we see how to draw out grids and we see how to access a two-dimensional thing, right? Because each one of these is considered basically a list of 5 objects. And so for that one, you would just print out A instead of, instead of the asterisks, right? So this is basically how you would do that. Oh, what do you mean then? While I pretend to go on to the next topic. So, to print out the letter A in stars. So that would be complex, right? Because either you program it in as a list, or you do some parametric stuff where you say like, I mean, yeah, I get you now. I understand what you're saying now. Yeah, I understand. I understand perfectly. Yeah, so if you wanted to do something like that, that's like a challenge type problem. That's really hard. Hard to do. Unless, of course, I mean, so it's always possible you could just, you could always just say print and then just do something stupid like this, where you kind of like program in, literally you could do this, right, as a big string, and then, so this is the cheesy way to do it. So this is cheese. So let's do it this way. So that'll do that. To do it with for loops, it might be a little harder. Like, you would have to put this all into a list, and then there's a lot of stuff you'd have to do. It's just, unfortunately, it's to do it the real way, to do it in a way that would probably satisfy you, would be slightly more complicated and slightly less cheese. But yeah, if you ever need to print a multi-line thing, this is, yeah, basically you can do pixel art in Python and you can just copy paste it, right? Because it has these multi-line strings. So these technically here, these are multi-line comments, but they are also multi-line strings. So if you actually assign it to a variable, then you can actually use them. So, okay, here's an aside. This has nothing to do with for loops, but it does have to do with 201. And so what it has to do with is that I want to talk about if name equals name. Okay, so we're going back a little bit to if statements, but that's okay. So in general, what I'm going to require that you do is all of the code that you submit from now on, and maybe not from this homework, so not the homework due this week, but in the future, so starting on homework 3, all code will have to be put inside of these if name equals main blocks. And there are reasons for it. The real reason that I'm doing this so early is just to get you into the practice of it. Right now, there's no reason for you to do this, but that's only because you know for loops, if statements, and a little bit about variables. But once you know a little bit more, once we get a little bit further in the course, there will be reasons. Generally, the reasons are if you use multiple files rather than just one file. So that's the main reason that you need this statement here. And so we're going to get into the practice of using it just for reasons. Not on the past homework. Not on the past homework. We're going to start in future homeworks. And not on the homework due this week. So not on homework 2, right? Not on homework 2. You can do whatever you want on homework 2. So you might ask the question, like, what is this doing? The answer is that what it's actually doing is every Python file has a secret variable called name, right? And we can print out name, so let's print out name and see what happens. What have I done? Oh, whoops. Okay, there we go. 1, 1, 1. So you see that here it says that the name is equal to main. And you might be thinking to yourself, but wait, the name isn't main, the name is second_lecture. Okay, I agree with you. But what about this file? So let's import. So this is something that you won't learn until further on in the course, but this is the reason why we're making you do this. If we import if name main, oh, you know what I have to do? I can fix this little red underscore. I can fix it. Mark directory as sources root. Ha, see, I've done it. I fixed it. Okay. So it's an unused import statement, but who cares? So let's do this. So let's run this code again. I'm going to remove 1, 1, 1, 1. Interesting. Where did this if name main come from? It didn't come from the import statement. If you take this, what it came from is that there is a print statement in this file, and so it knows its own name. And you might think, well, why doesn't this file know its own name? Why does it think it's called main? And the answer is because this file thinks it's called main because it's the entry point. Right? This is the file that we clicked run on. Right? So we clicked run on this file. We didn't click run on the if name main file. Right? That file never got clicked on. So, yeah, that's exactly right. So what it does is it changes the name of whatever the main file is to __main __, all in a string. So it changes it to a string, and that's what it, well, it doesn't change it to a string. It changes it from second_lecture to __main __. And so that's how this if statement works. And so basically what you're gonna have to do is just put all of your code inside of these if name equals main blocks. And again, you might think there's no point. And you're right. As of this exact moment, right now, there is no point to doing this. But when you get to the projects, when you get to later homeworks maybe, but definitely on the projects, there will be a point to this. There will be a reason for using this. So that's kind of the issue here. Okay, so I know that we're teaching it early, and we're teaching it early because it's a good habit to get into. So whatever code that you run, just put it in an if name equals main block and just tab it in by 1. So you can even do it on homework 2 technically, but I'm not going to take off any points for that. It's going to start on, we'll start this on homework 3, and once I make sure that everybody knows about it. Okay. Let's think. All right, so that's and if you don't understand all this stuff about imports, like technically imports are forbidden currently, so don't worry about them. We'll talk about what they're exactly doing. I mean, obviously you know that it's opening this file and sticking it in there somehow, so clearly you kind of know what it's doing, but if you're confused about it, don't worry about it. The only thing you have to know is that you have to stick the if name equals main block onto your code, and that will make us all, it makes the TAs very happy right? It just makes us very happy. And don't you want to make us happy in the end? Isn't that what you want? I think that's what you want. So I'm going to go with that. Okay. So the last thing I'm going to do is yeah, I mean, it's forbidden right now, but once we teach imports, then it becomes unforbidden. Basically, the way that this class works is that everything is forbidden until we teach it. So currently, on homework 2, for loops are forbidden. Oh, you know what? We can do tuples right now, because I think we only have, like... So we started the lecture a little bit late, but I'm going to end it mostly on time. No, all the lines of code. So, okay. So let's talk about tuples. So, tuples are lists. Tuples are basically lists. We don't really require tuples in this class, but Python uses tuples for a bunch of stuff, and you might see them and all that. So instead of doing a new list equals to new list with stuff inside of it like this, a new tuple is, say, equal to, and you just do parentheses like this. Like this. Okay? And then you can even access them using a for I loop, or for each loop. So you can say for x in new tuple, and x like this. So a tuple works basically the same way as a list. Let's remove 4. Okay, so you see here at the very end it printed out ABCD, and so you might be asking, what is the difference? Right? I believe you, so you believe me, right? You definitely believe that a list and a tuple are basically the same. The only difference is you can't modify tuples. So let me show you what I mean. If I said new tuple at element, say, 1 is now equal to my favorite letter of this lecture, which is Z, and then we print out new tuple. Now, of course, it's yelling at us here, right? You notice that the whole thing is grayed out. This is PyCharm trying to hint to us that we've done something wrong. Tuples don't support item assignment. And so when we run 1, 2, 3, whoa, shouldn't have done that, 3, 3, and then it says tuple does not support item assignment. So what does tuple does not support item assignment mean? So if you remember, this is the same error that we got with strings. And the whole point about that is that strings were immutable. And if you notice what the word immutable probably means, it means something that cannot be mutated, right? Which is like basically a modification of in, right? Immutable. So immutable means cannot be changed. And so tuples are immutable lists. And that's really it. So that is exactly all I need to say about tuples, because tuples have basically all the same functionality, all the same everything as lists. The only difference is that they're immutable. Now you might ask, well, why do I ever want an immutable list? And the answer is, who cares? Like, if you ever want an immutable list, if you ever are like, this list will never change, you can make a tuple out of it. But in general, you want a list, right? Most of the homework problems, most of the test questions, almost everything, I'm never actually going to ask you about tuples. You are allowed to use tuples, but we are not going to require you to use tuples. Mainly because you can use, if you just don't change a list, then it's essentially immutable too, right? So as long as you don't modify it, then it's okay. So that's basically the exact opposite of that. You can change lists, but cannot change tuples, right? And you see that here, because this gave us an error, whereas assigning new things into a list is definitely possible, right? If this were a list, you can assign into it, but it's, yep, okay. So I think I know I've robbed you guys of about 5 minutes worth of lecture because I started late. Mainly in my defense because I'm an idiot and just didn't realize that OBS still had me on the waiting screen. So I literally was just talking into nothing. But on the other hand, class time has been over for 2 minutes, and so that will be it for today. I do not want to steal too much more of your time. We will do one more lecture on lists and loops. We will talk a little bit more about for loops and about lists, probably 2D lists. We'll do a little bit more in terms of like drawing out star patterns and stuff, cool stuff like that. And that's really it for today. So, yeah, hopefully I can find OBS to turn everything off now. All right, everyone. See you later. Yeah, it'll be on GitHub. You know what? I'll post it right now so that I'll post it right now because I forgot last lecture. Let's do it. Push. Okay. Once it pushes, we can sign off. All right, that's it. We're good. I think we're good. Talk to you later, everyone.